All right, we get to continue on here with piecewise functions. This time we are going to write the equations of piecewise functions. So in order to begin, we need to first talk about slope-intercept form. Nice little throwback to Algebra 1 here. Y equals mx plus b, where m is the slope and b is the y-intercept. Point slope form, maybe just a little bit more useful, is y minus y1 equals m times x minus x1, where m again is your slope and x1 comma y1 is any point on the line. All right, so example number 1. Write the equation of the piecewise function. So I'm going to go ahead and just split my workspace in half here. On the left side, we're going to go ahead and write the equation for this line here. So the first thing I probably want to identify is where are we splitting these functions at? What is the x value here? If you look at the graph, it actually tells you right there, -1. So the blue line there that I have drawn over, we are only going to graph that for the x values that are less than or equal to 1. And it's less than or equal to because of this closed dot at the starting point there. So less than or equal to 1. So now we have our domain restriction. I need two pieces of information though. I need my slope m and I need my b value, my y-intercept. So if I were to pick 2 points on that line, it looks like right here is 1 and right here is 1. And if I count rise over run, it looks like I'm going up 1 and to the right 3. So my slope is 1/3. If you were to continue that, sometimes that's the best option to find the y-intercept. If you were to continue that, go up 1/3 and continue that line, you'll see I don't really cross the y-axis there at a nice point. So here's where your point slope form comes into play. I do have my slope and I do have a point. You can pick either one of these 2 points here. I'm going to go ahead and use -1, 1. So I have m as 1/3. I have x1, y1 as -1, -1. Plug them in up to point slope form, right down here. So y minus -1 equals 1/3 times x minus -1 again. Through the magic of algebra and doing a little bit of cleaning up here, we can simplify this to y plus 1 equals 1/3 times x plus 1. We can distribute the 1/3. And we might as well go ahead and subtract 1 from both sides. So y equals 1/3 x minus 2/3. And if you continue, that line, that's kind of about where that's at. You maybe could have made an educated guess, but I'd rather see an exact answer. So we have our first part of the piecewise function right here. Okay, let's go ahead and find the equation of this line. Going to be a similar process. So this time we already know where the split's happening. It's happening at, I should have probably fixed that, -1. But this time we want all x values greater than -1. So that's my domain limitation. I can find my slope rather quickly, again, by picking 2 points. So we might as well use this one and that one, counting rise over run. So it looks like my slope is -1. And we also need our y-intercept. Now this one is actually less work involved because I can find that point quite easily. I'm crossing the y-axis at a value of 1. So I have m, I have b. I can write my equation, y equals negative x, that's my slope, plus 1. Now that you have both of your equations, we can go ahead and write our piecewise function. So we're going to start off with f of x equals, then we're going to do the sweet little curly bracket. I'm going to put my first equation up top, so we had 1/3 x minus 2/3, comma, if that equation's only good for the values of, or when x is less than or equal to -1. It's only good then. So you got to make sure to include that domain restriction. And then we're going to put the second equation, negative x plus 1, if, and this equation's only good for the x values greater than -1. And there you go, finding two equations, writing a piecewise function. Final answer. All right, second example. These are all very similar here. So start with finding your split. Where are these two equations splitting at? If you look, draw it in there if you really want. Certainly not required to, though. We are splitting at +1. Whoa. I'll split my workspace as well. So let's start with the equation off to the left. Where is that happening? Or when is that equation good? For the x values that are less than 1. And it's less than again because of the open circle here. I'm not including 1 for that equation. Okay, I need two pieces of information. I need my slope and I need my y-intercept. So you can see right here I'm crossing the y-axis at -4. And you can pick any 2 points on the line here. Maybe zoom in a little bit. If you count rise over run, our slope is -1. So actually this was quite easy. We can go ahead and write our equation, y equals -x minus 4. I'm just using slope-intercept form, if you're wondering where those values are coming from. So first one is done. Now let's move on to the second one. So we're starting here and we're going up. So this equation is only good for the x values that are greater than or equal to +1. Okay, same thing. I still need my slope. So we can go ahead and count rise over run real quick. Here's another point. Looks like we're going up 1, 2, 3, and over 1. So there's my slope, 3. Now my go-to move here before I use point slope form, my go-to is to see, can I extend this graph and find my y-intercept? That's always going to be the easiest thing to do. So if I keep going 3 and over 1, you'll see right there I found my y-intercept. So I can save myself a little bit of time. I'm crossing the y-axis at 0. So my second equation then is going to be y equals 3x, and I mean, you shouldn't really have that +0, so I'm going to leave it off. I have my two equations. Let's go ahead and write the piecewise function. Starting with f of x equals, sweet curly bracket. Let's take the first equation I found. Let's go -x minus 4, comma, if it's only good for the x values less than 1. So don't forget that domain restriction. Second one is just 3x, comma, if x is greater than or equal to 1. And that's it. Answer. Second one done. So this one is very similar. Example 3 is very similar. Oh, we got two example 3s. Sweet. Let's go on to the second example 3 where we have 3 lines. That means this time we're going to need 3 equations, and we got all kinds of workspace, so that shouldn't be an issue. But let's start here at the far left with that line right there. So first of all, we are splitting. If you want to draw it in again, go ahead, not required. But this line is only good for the x values that are less than -2. And it's less than again because of the open circle there. I need two things. I need m and I need b. So let's go ahead and find those two things. I have to erase this line a little bit because it made it a little sloppy. But if we pick 2 points, we got a point there and a point down here. If we count rise over run, 2, 3, 4, 5. 1, 2, 3. 5 over 3. Of course, it's not going to be very nice. So my slope here is 5/3. Okay. If I were to continue that pattern up 5, I'm going to be somewhere up here, and I'm going to cross somewhere here. But I don't know what that is, so that's where you got to go back up and say, okay, we need point slope form. So let's go ahead and bring that down. Y minus y1 equals m times x minus x1. So I have m already. It's 5/3. I need x1, y1. And that's any point on the line. So I'm going to go ahead and use this point right here. Erase some of this work. I'm going to go ahead and use this point right here. The coordinates of that point are -2, 2. So y minus 2 equals 5/3 times x minus -2. Let's go ahead and clean this thing up. Y minus 2 equals 5/3 times x plus 2. We got two negatives back to back right here, so you might as well clean that up. Now we have to distribute 5/3. Sweet. Oops. There we go. So y minus 2 equals 5/3 x plus 10/3. So far, we're good. Let me make sure here. Yep, okay. Go ahead and add 2 to both sides. So y equals 5/3 x plus. Now, a little side note, a little throwback to, gee, I don't even know when you add fractions. But if I want to take 10 over 3 plus 2, I need a common denominator. So 2 we can rewrite as 6 over 3. Yeah. Let me make sure we're good here. Okay. 10 over 3 plus 6 over 3 is 16 over 3. So there you go. First equation done. It's as simple as that. Just kidding. That was a little more work than probably necessary. Now, let's go ahead and find, let's pick a different color here. Let's go ahead and find the equation for this straight line. And I did mention in the prior video, if you recall back to the early units in Algebra 1, a horizontal line, the equation of that line is always just y equals, and then whatever number wherever it crosses the y-axis. So if I count up here, 1, 2, 3, 4, the equation of that line is y equals 4. It's that easy, but we also need the domain restriction. So this line is only good if x is between the values of -2 and +2. So here's how we're going to write this. We're going to put x, and then we're going to go -2 to the left side, +2 to the right side. On the left side, we're going to have a closed circle, so we're going to go less than or equal to sign there. On the right side, we have an open circle, so we're going to go less than there. Okay, so hey, 2 down. We did a lot of work on the first one. We made up a lot of time there for the second one. So now let's go ahead and find number 3. So same thing here. Let's try to split up my workspace a little bit. Okay. Same thing. We need M. We need B. Your slopes be pretty easy to find. Pick 2 points. count rise over run. So my slope is -2. If I continue that pattern, if I rise 2, run 1, if I keep that thing going, I'm going to cross up here. And I know I'm off the graph, but hopefully we can think about this one a little logically. You know, you can count up 1. It's going to be close enough. 1, 2, 3, 4, 5, 6, 7. Again, if you can do it that way, save yourself some time. Please do that. So the third equation is y equals -2x plus 7. So now we have all three equations written. Let's put this thing together. Actually, hold on. We have to go back here and decide when is that equation good. The split here is happening at x equals, or where x is 3. So we can say that this equation is only good for x is greater than or equal to the values of 3, because we're going to the right, and it is a closed dot. So now we have all the information. Let's go ahead and put this together, starting with f of x equals a nice little squiggly bracket here. Got to make it a little taller this time because we have 3 equations. The first equation will go first, so y equals 5/3 x plus 16 over 3, comma, if that equation is only good for the x values less than -2. Jumping over to the second equation. Shoot, I didn't mean to put the y equals in there. I was wondering why it was so long. Just 5/3. Okay, the second one is just 4, comma, if our x values are between -2 and 2. And then the last equation is -2x plus 7 if the x values are greater than or equal to 3. And there you go. That's about as difficult as writing piecewise functions can be. There's just 2 examples again, and that takes care of piecewise function.